Yep, true, quite right. So the good thing about this last section that we're doing today is that it's very similar to what we did yesterday, kind of, in the way that yesterday we were trying to plot, was it yesterday? Yeah, yesterday. We were trying to plot graphs given some information, and we used the y-intercept as one point, and then we used our gradient to find another point, and then we matched up those 2 points, and ta-da, we got the equation of the line. What we're doing today is just looking at a slightly different situation where instead of trying to figure it out with the y-intercept and the gradient, you can still use the y-intercept, that's fine. We're going to be using, in fact, we are still using the y-intercept. We're going to use the y-intercept and the x-intercept. And there's a way to find both of those things out. The y-intercept, does anyone recall how we find the y-intercept? Where does the y-intercept occur in regards to the x-axis? At x equals 0. So that means if I have an equation and I substitute in x equals 0, like this equation I have here, if I substitute in 0 for x, and then it would be 2 times 0, which is 0, and I have 3y equals 12, and solve for y, then that would tell me what the y-intercept is when x equals 0. Well, I mean, what the y-intercept is regardless of anything. It just happens to be that it always happens when x equals 0. Okay. Now, the converse of, I don't know if converse is the right word, but the converse of that is true as well, that I can find the x-intercept by substituting what for 0? Y. So if the y-intercept occurs when x equals 0, then the x-intercept is going to occur when y equals 0. And that's it. We essentially just do 2 substitutions, and the 2 results we get are the y-intercept and the x-intercept. So this is essentially the notes for this section, this part here. So to find the x-intercept, substitute y equals 0 into the equation, and that means whenever you see a y, you replace it with 0, and that's it. And to find the y-intercept, substitute x equals 0 into the equation. So when you're trying to find the y-intercept, you see an x, you replace it with 0, and whatever is multiplying with that is going to go to 0, and so on and so forth. Okay. So I'm going to write out exactly what I wrote there. So this first work example, I'll just give you a minute to write down those 2 things, because I'd like that. Who's writing down things? Hopefully everyone. The first work example, we're just going to put essentially those 2 principles into practice. So find the x-intercept and the y-intercept for this equation and sketch it on the graph. Okay. So firstly, let's start off finding, which one should we find first? Well, the y-intercept is always the easiest because it's always y equals blah. And actually in this situation, because the equation is written in this way, it doesn't matter. Either way, it's going to be just as easy. Let's find the y-intercept first. So the y-intercept implies x equals 0. And that implies that 2 times 0 plus 3y equals 12. What's the next line going to look like? What's that 2 times 0 going to go to? Yeah, 0, nothing. It's going to disappear. And then I've got 3y equals 12. How do I get y on its own? Divide both sides by 3. And so I get y equals 12 on 3, which is 4. Great. What does that tell me? Y-intercept is 4. Yeah, when x equals 0. Great. So I can actually just plot that point now. I've got when x equals 0, y equals 4, or x equals 0 along this line is here, pretty much. Try and draw that a little bit better. Is there. And y equals what at that point? Sorry, I shouldn't put a dot there because that's not where I'm looking at this position here. And 4. So that's where my y-intercept is going to occur. Right there, when y equals 4. Cool. If I were to write that as a coordinate point, what would it look like? 0, 4, yeah. So 0, 4 is the coordinate point because remember x always comes first, followed by y, and that is my first point for the thing. Okay, for the x-intercept, x-int, well that implies what? That y equals 0. Okay, it's all right. So x-intercept is implying that y equals 0, and so that's going to look like, so 2x plus 3 times 0, fix that, equals 12. Great. So that's obviously going to go to nothing. So I'll go x, 2x. 2x equals 12. And how do I get x on its own? Yeah, divide both sides by 2, exactly. So x equals 6. Great. What's that as a coordinate point? 6, 0. If I find that on here, I'm going to go across to 6 and at 0. Great. Now I have 2 points. And I can get the ruler and bring that across, line that up between the 2 points. Well, I think it needs 1 more degree. That's close enough. Looks like it's 30, halfway between the two, 33 and a half. But that'll do. There's my line. And that is the equation 2x plus 3y equals 12. Incidentally, 2x plus 3y equals 12. What if I wanted to convert that to gradient y-intercept form? I essentially want to get y on its own on one side. So if I wanted to do that, what's the first thing I would do? What I could do? I'll move the 2x over, yeah. So I'll take 2x from both sides, and so I'd get 3y equals 12 minus 2x. And now I want to divide everything by 3 to get y on its own. So y would equal 12 divided by 3 is 4, and 2 divided by 3 is just 2 over 3, x. So what's my gradient? Negative 2 over 3 is the gradient, good, and the y-intercept is 4. Well, if I have a look at my graph now, I can see, yeah, the y-intercept is at 4, that's good. And negative 2 over 3, well, if I pick 2 points, I can start here, and then it's negative 2 over 3, so it's a negative 2 rise, so down by 2, and a run by 3. 1, 2, 3. Oh, look at that. It fits. It works. My gradient has worked. I've drawn the correct line, and good times are to be had. Deleting all of that. Redoing that last part. Okay. Any questions about that? So we're just finding the x-intercept and the y-intercept, using that as 2 points, and plotting the graph. Sorry? Yeah, sure. Of course. Yeah. So you can write that down now. Just put it like that, and yeah. Just to specify, the y-intercept is this part here, 4, and the gradient is negative 2 over 3, which is the rise over run. So the rise is negative 2, and the run is 3. Okay, no worries. That's it. So there is one more worked example, but it's essentially the same thing. So I can just leave that there. Unless anyone wants me to go through the next one? Yes! Okay. Yeah, that's so good. Okay, so find the x and y, it's the same thing, but different numbers. Cool, we can do that. So the y-intercept is occurring, the y-intercept always occurs at x equals 0. So I'll substitute, thanks Jess, x equals 0 into that. So 5y minus 4 times 0 equals 10, which implies that 5y equals 10. And so what must y be? Anyone? What must y be? If 5y equals 10, y equals 2. 7. It's a 5, 5y. I divide both sides by 5. You just, okay, yeah, well, okay. We're not there yet, are we? Okay, okay, so that's fine. As a coordinate point, that would be 0, 2. For the x-intercept, same deal. I'm going to have 5 times 0 minus 4 times, x, it's just normal, equals 10. And obviously that's then going to be negative 4x equals 10. And how do I get x on its own? Divide by negative 4. Yeah, exactly. Same as what we always do. So x equals 10 on negative 4. And what does that equal? That can simplify to be, let's quote my negative out the front. Sorry? 5 over 2, yeah. Negative 5 over 2, which is 2.5. And that's fine. So my coordinate point there would have been, or would be, negative 5 over 2, comma 0, or negative 2.50 if you'd like to use the decimals. And we have 2 points there. So 0, 2 is my first one, so 0, 2. And the next one was negative 5 on 2, 0. Negative 5 on 2 is negative 2.5. It's about there. And those are my 2 points. Get my ruler out. Is my gradient positive or negative here? Yeah, positive. The graph's going up. It's a good thing to note. And essentially done. I've plotted it. As a side note, I could rearrange this to get the x and y intercepts, and I'm going to just for fun, but it's not asked in the question. So we had 5y minus 4x equals 10. I'd have 5y equals, well, 4x plus 10. Y equals 4 on 5x plus 2. So my gradient there is 4 over 5. So I'm rising by 4 units, running by 5 units. And my y-intercept is 2, which I can see it is. It's 2. So if I picked that point there and this point here, let's pick those 2 points because they're nicely going through 2 intersections, this point and this point, rising by 1, 2, 3, 4, and running by 1, 2, 3, 4, 5. It works. Great, it's there. The gradient is correct. And that's it. Any questions? Nope, we're done.